next question, number 4. Consider a function f is equal to 1 by r square r cap, where r is the distance from the origin and r cap is the unit vector in the radial direction. The divergence of this function over a sphere of radius r, which includes the origin, is. So we have our 4 options A, B, C and D. Now in this question, you'll have to note this part, includes the origin. Now this is very important. As we solve, I'll show you what I mean about this. So we have to find out the divergence of 1 by r square r cap. The point is that the further away you move from the origin, the vector field expands rapidly. And in order to calculate the divergence, we have to start with the dot product of the vector field. So that would be delta dot vector field F. And that in terms of, now we are talking about the sphere of the radius. So we are going to work on spherical coordinates. So delta dot F bar would be 1 by r square dou by dou r into r square of the function given to us, f. So that's 1 by r square dou by dou r of r square into the function f. Now let's see how we can solve this further. Here f is the function 1 by r square r cap. So if we substitute, we get 1 by r square dou by dou r of r square into 1 by r square r cap. Okay, so here we see that r square and r square cancels out and we are left with just 1. Delta F equals 1 by r square dou by dou r of 1. And we know that the differentiation of a constant is 0. So delta dot F bar is equal to 0. So that means that the divergence of the function is 0. But then here's the point. It includes the origin. Now because it includes the origin, this cannot be the answer. Radius is equal to 0, r is equal to 0. So here, this cannot be the answer. So we don't know the divergence at the origin. And so we will have to apply Gauss's theorem in the next step. So if we apply Gauss' theorem, I'll write it down here. Now we will have to look at Gauss' theorem. Gauss's theorem says that for a simple solid of a certain region, and if S is the surface vector, then we will have the notation the volume integral. The volume integral of delta times the volume d tau is equal to now the surface integral. Okay, surface integral of the same volume dA. Now here dA corresponds to the sphere. We are going to work on only spherical coordinates. So this would now equal to, here we are working on sphere of radius r. The volume or the function given to us is 1 by r square r cap. Now dA, okay, this is dot product, please note, it's delta dot V, so that's dot product. Okay, so dA bar corresponds to r square sine theta, because we are working on spherical coordinates. So that's d theta d phi. Now we will have to expand this and write it in integral form. So here we have, now r square and r square cancels out. So we will have the surface integral of sine theta d phi. So if we split this, we will have theta is equal to 0 to pi. We have to be very careful with the limits here. Now theta corresponds to 0 to pi. It doesn't complete a whole circle. It completes just from one end to the other. So that's 0 to 180 degrees. Sine theta d theta. Integral of phi. Now phi corresponds and it represents all the 4 quadrants. So it's 0 to 2 pi d phi. So now this is our integral. If we solve this, we'll obtain minus cos theta from 0 to pi and phi from 0 to 2 pi. Now I'll work the rest out over here on this corner. Now minus cos theta from 0 to pi, if we substitute the limits, we get minus cos pi plus cos of 0 times 2 pi. This is 2 pi. Now this would be 1 minus cos of pi is 1 minus of minus 1 into 2 pi. And this is 2 into 2 pi, which gives us a value of 4 pi. So this is our final answer. Let's see which option it matches. It matches option C. So this is the final answer. I hope the solution is clear.